Hello everyone, welcome back. Today we're going to continue on with our Taylor-Maclaurin polynomial series. The last video that I did, I showed you guys two examples of a Maclaurin series for e to the x and sine of x, and we used this lovely equation right here where c was actually equal to 0. Well, for today I'm going to do two examples of a Taylor series, and the very first one is going to be right here. So in this case here, it's going to ask us to find a Taylor polynomial series of degree 4 for the cosine of x, and this time we're actually centering it at pi over 4. Now for a Maclaurin series, we would make the assumption that c would be equal to 0. So for this one, it requires a little bit more work than what we did for the previous example. But if you look back at the equation for one quick second, we're going to do the same thing we did for the Maclaurin series. We're going to find each little term, and since it's asking us to go to a degree of 4, we're going to go up to where x to the 4th power is going to be. So I'm going to just talk about the equation down here without referencing. I'll reference it, but we don't need to look at it. So what we're going to do is we're going to first of all find what f of c is. Right? That's the very first term that we need to do. And so f of c is just going to be the cosine of pi over 4, and that's going to be equal to 1 over the square root of 2. And I know some people are like, oh my god, that's the square root of 2 over 2. In calculus, doesn't matter. They're the same thing. We don't have to rationalize. You don't have to simplify. So if you feel more comfortable, I can write the square root of 2 over 2 as well, but I'm going to use 1 over the square root of 2 in my answer. But they're the same thing, and both of them are completely fine. So when we're starting to write our series over here, so this is going to be p of x, our first term is just going to be 1 over the square root of 2. All right? So it's pretty straightforward for that particular problem. And now let's look at the second term that we have to do. Well, this is all about the ones, right? So this is where we have to find the first derivative. So let's first find the first derivative, and I'll talk about that in a second, all about the ones. So the derivative of cosine is going to be negative sine, right, negative sine of x. And then I'm going to find f prime of c. Well, I'm going to find f prime of c, which is going to be pi over 4, and that's going to give me negative sine of pi over 4, which is going to give me negative 1 over the square root of 2. 1 over the square root of 2. Okay? And so this will be you guys will get the gist here. So what we're going to do here is now I'm looking at this term right here. I'm looking at this equation. And so I found the first derivative. And this one said this is all about the ones because it's the first power. It's the 1 factorial. So what I'm doing is I'm finding the value of the first derivative at c. And then I'm going to then just plug in values for right here. So let's look down here and write up what I want to continue this with. So for this next term, I'm going to do, okay, minus 1 over the square root of 2. And then I'm going to multiply this by x. Remember, it's x minus c, right? X minus c, so we have to do pi over 4 to the first power. And it's all over 1 factorial. I'm going to go ahead and write that just because we want to remember. And we're going to clean this up a little bit later on. All right, so I found the first term, and then this is f prime of c, x minus c to the first power, all over 1 factorial. So this is all about 1, right? This is all about 1. Let me clear this up a little bit more. So that's a multiplication, this is subtraction. All right, so let's look at the next one. Well, we're going to find now the second derivative. So this next term that we're going to do, it's all about the 2's, all about the 2's. So we're going to find the derivative of negative sine, and we're going to get negative cosine of x. And we're going to go ahead and plug in pi over 4 to that. And we're going to get negative cosine of pi over 4. And then what we're going to do with this problem is it's going to be negative 1 over the square root of 2. Okay? And so we're going to go ahead and now do our next term. And again, it's all about the 2's. So our first thing is we're going to do 1 over the square root of 2. Right, or the square root of 2 over 2 if that's what makes you feel better. And then we're going to multiply that by x minus pi over 4 squared all over 2 factorial. So again, it's all about the 2's now, right? We found the second derivative and we plugged in c. We have it raised to the second power and we have 2 factorial. Okay, so let's continue on. So then I'm going to find my third derivative. Right, my third derivative. And so my third derivative is going to be the derivative of negative cosine of x, which is going to give us positive sine of x. And then f, let's just do of pi over 4 is going to be the sine of pi over 4, and that's going to give us 1 over the square root of 2. right? 1 over the square root of 2. So now let's write out our third degree, or our fourth term. So now I'm going to do plus 1 over the square root of 2. And again, this is now all about 3's, right? So it's going to be x minus pi over 4 cubed all over 3 factorial. All right, and so it's asking us to find a degree of 4, so we have one more step we have to do. We're going to go ahead and write our fourth derivative, and that's going to be the derivative of sine, which is cosine. And notice that, oh right, we're right back here. Notice we're right back here again, so it's going to be the same thing. So we're going to go through the same patterns again with this. We automatically know what the cosine of pi over 4 is, and we decided that that's going to be 1 over the square root of 2. And so our final thing that we want here is going to be plus 1 over the square root of 2 times, and again, now this is all about 4, right? All about 4. And so this looks really messy, and I apologize for it, but this is what we're looking for this particular example. What usually happens on the BC exam is they factor out something that's common here, and you guys can see that as 1 over the square root of 2. And actually, let me just go ahead and write out what that will look like right here. So what you would see on the BC exam. So I'm going to go ahead and factor out a 1 over 2. And so this first term here is just going to be 1. And then my next term is going to be x minus pi over 4. Right, and sometimes they group it, sometimes they don't, but that's going to be our first term. So this is completely simplified. And then we're going to go ahead and do minus, and this is going to be x minus pi over 4 squared over 2, right, over 2. And then we'll do plus x minus pi over 4 cubed over 6. And then finally plus x minus pi over 4 to the 4th over 24. So this is this nice way of writing this little mess that's written up right there. All right, so that's my example of showing you guys how to find the Taylor-Maclaurin series for a degree 4 of cosine of x centered at pi over 4. And the last thing I just want to say about this is that just please be careful that you don't forget to subtract the c's when you're writing these things out, because students are so used to Maclaurin where c is 0, but you have to remember that when you're doing a Taylor series, you need to remember to subtract the c's from each one of them. Alright guys, so let's go ahead and look at our other example for a Taylor polynomial series. And this example is actually asking us to find the first 4 terms. It's given us the function, the natural log of x, and it's asking us to evaluate it at x equals 2. So just a little housekeeping here. So it's actually telling us that our function is the natural log of x, and it's saying that the c value, if you're looking at the equation, is equal to 2. All right. So the first thing that we want to do here is we want to actually find the very first term. Well, the first term is just what is f of c, right? What is f of c? Well, f of c is going to be the natural log of 2. And that's exactly what we want. That's our very first term. So we're looking for 4. We found the very first one. So what I'm going to do down here is I'm going to go ahead and write down what our series is. So a piece of x is just going to first of all be the natural log of 2. So we've got our first term already done. Pretty easy. All right, so let's look at the next one. So we got to find the first derivative. So we got to find the first derivative. So the natural log of x is just going to be 1 over x, right? Classic derivative for the natural log. And so what we're going to do now is we're going to find f prime of 2, which is going to give us 1/2. So then when I want to write down our term for this, well, remember the second term is actually going to be 1/2. And remember, it's all about the first, it's number 1, right? First derivative. So it's going to be x minus 2 to the first all over the first derivative. So that's what we're going to do with that. And then down here, we're going to simplify it a little bit more. And so we're going to be left with plus 1/2 times x minus 2. All right, so there's our second term. All right, and now let's keep on going with our third term, which would be our second derivative. So everything that we do is all about the 2's. And so the derivative of 1 over x is negative 1 over x squared. And actually, let me just say something really fast about this, because I tell students that 1 over x and the square root of x should be two derivatives that they should know pretty well. But let's go ahead and make this x to the negative 1. And then the reason I'm showing you guys that is that if I'm asking you guys to find multiple derivatives for this, then I just want to leave it as negative x to the negative 2. These are the same thing. So when I plug in f double prime of 2, I'm going to get negative 1 over 2 squared, which is going to be negative 1/4. And then I'm going to multiply that times x minus 2 squared all over 2 factorial, right? So this is now our third term. Over here, it's going to be negative, and then I'm going to go ahead and do x minus 2 squared for the top. And then usually multiple choice questions, they're going to give you a simplified version of this. So we got a 4 and we got a 2 factorial. Well, this is just 2. So we're going to go ahead and we're going to leave that as an 8. All right. And then our last term that we're going to look at, which would be our third derivative, right? So we're going to look at our third derivative of our function. And so this is why I said let's go back over to here for a second, because this is actually easy to find. So then it's going to be 2x to the negative third power, right? Just using the power rule. So 2x to the negative 3. And then when we're plugging in, right, we're plugging in what 2 is. Well, it's just really 2 over 2 to the third, right? So this is 2 over 8, which is going to give us 1 over 4. So now I know that my term is going to be 1/4. And then since I'm looking at it's all about the third, right? 3, 3, 3, 3. So this is going to be the final term, right? So when we write our last term out, it's going to be plus. We're going to do x minus 2 cubed. And then on the bottom, we're going to see that it's going to be 4 times 3 factorial. Well, 3 factorial is 6. So it's going to be 4 times 6, which is going to give us 24. All right. So this is the Taylor series for the natural log of x at c equals 2. So I hope that makes sense. And yeah, I will see you guys in the next video.